Hello and welcome to lesson 5.3. So once again, just to reiterate, this chapter is all on doing stuff with polynomials. We started with adding and subtracting polynomials and we wanted to dive right into multiplying, but we couldn't without some exponent rules first. So now that we've covered exponent rules, I think we're ready to multiply polynomials and we're ready to divide them, but we're only going to do multiplying today. So to do multiplying polynomials, the main thing we need to remember is we need to recall the distributive property. We've already done that, like back in our very first lesson, but I'll start with a simple distributive example to see if we're ready kind of to mosey forward. So this technically is multiplying a polynomial times a polynomial. This is a polynomial with two terms, 5x plus 6, and this known as a binomial. And this is a polynomial with a single term known as a monomial. And so I'm able to multiply these simply by using the distributive property, which says this 3 can be multiplied or applied to both of these. 3 times 5x is 15x, and 3 times 6, positive 6, is positive or plus 18. So if I can do that, I can surely expand a little bit more where I may need some things like exponent rules. Like what if I were to do 4x times 2x plus, oops, I forgot the plus sign, plus 3. And the answer is, yeah, this works exactly the same way. 4x times 2x squared, well, the 4 times the 2 makes 8. And x times x, remember we have exponent rules for this. X to the first times x to the first says when I'm multiplying like bases, I add the exponents, and that's x squared. So this first term is 8x squared, and 4x times positive 3, well, that's positive 12x. Okay, so I can handle multiplying or distributing by a single term. What if it's not a single term? What I mean by that is, what if I give you something like this? X plus 4 times x plus 5. So this is definitely a two-termed polynomial times a two-termed polynomial. This is not a single number. Well, a lot of people take all this time teaching you this thing called FOIL. They say, oh, combine the first, inside, outside, last, or outside, inside, last. And you have to remember what that stands for. Well, it's not that hard, but you have to sit there and say, okay, FOIL, we're going to do the first terms together, and then inside, outside terms, oh, we already did the outside, and then the inside terms, and then the last terms. I think that's a little bit stupid, because then if I change the size of these polynomials, you're up a creek. FOIL doesn't work anymore. So I just call it a super distribute, okay? Super distribute. And that's where you take everything in the first term, in the first polynomial, sorry, and distribute it to everybody in the second polynomial. So I'll have kind of two terms here that need distributing. So I'll kind of take my time to do two different distributes. This positive x times an x makes x squared. This x times a positive 5 makes a positive or plus 5x. Now this x has been distributed to everybody in the other polynomial, so this 4 needs to be distributed. 4 times x, that's a positive 4x. And 4 times 5, that's a positive 20. So everybody in the first polynomial was distributed to everybody in the second polynomial. Now, if you look here, I'm not finished yet because I can still simplify a little bit. And we want our answers always to be simplified as far as possible. And so you look, I have like terms I can combine. So x squared, 5x plus 4x means a positive 9x, and bring down the plus 20. Okay, so if this, I just think of this as a super distribute, that's not too bad. Then it doesn't matter how big of a polynomial, we would just take our time to distribute everything. Okay, I like that. That's nice. Let's do some more examples. I can try to get fancy and nasty and add even other variables and all sort of stuff, but we just take our time and do super distributes. So what about an example like this? We have 2x minus 2y, and I'm multiplying by 3x plus 5y. Well, we do the same thing. Every term in the first polynomial will be distributed to the second polynomial. And so 2x times 3x. Well, 2 times 3 is 6. And x times x is x squared. 2x times a positive 5y. Well, 2 times 5 is a positive 10. But what about x times y? What is that? Well, I can't do anything with that. That's just x, y. And I could literally write this in any order I want. I could write 10yx, 10xy. But it's good to put the number first in the letters in alphabetical order. It doesn't really matter, but that'll help us see when we have like terms. All right, the 2x has been distributed to everybody. Let's do the negative 2y. Negative 2y. So negative 2 times positive 3 is a negative 6. Y times x is just x, y. And then negative 2y plus positive 5y, that would be a negative 10. And y times y is y squared. Now with these, whenever you do have these sizes, you're always going to need to look for the possibility of like terms. And if you look, I have a 10xy and a minus 6xy. So those are like terms. 10xy minus 6xy gives us a positive 4xy. And bring down your minus 10y squared. Okay, this is not so difficult. Let's just do a few more examples before I kind of give a weird shift to this how about this? This is one a lot of people miss. 4x squared plus 5, and I would like to square it. A lot of people would like to try to use the exponent rule. Only problem is, do exponent rules apply across polynomials, across plus and minus signs? No, exponent rules only apply to single terms. And so I cannot use the exponent rule to give everybody exponent times 2. How am I going to do this then? Well, I'll go ahead and tell you. What does it mean to square something? It means to have it multiplied by itself, or to have it written out twice multiplied. So that would be, oops, actually there's a typo here. I did not mean to, we could still do this, but I did not mean to have 4x squared. Let's keep it simple. Let's get rid of that squared, sorry. But anyways, if I would like to square this whole parenthesis, that means I have this parenthesis twice. So I have 4x plus 5 times 4x plus 5. So if I expand out this exponent here and say, squared 2 sets of these parentheses, what goes inside each one? 4x plus 5. Now this looks exactly like all the problems that we just were taking our time to do. So super distribute. 4x times 4x. 4 times 4 is 16. X times x is x squared. 4x times 5. 4 times 5 is 20, and there's an x there. 5 times 4x, that is also 20x. And 5 times 5 is positive 25. And then, of course, I have like terms right here, 20x plus 20x. So I get 16x squared plus 40x plus 25. Now I'll go ahead and tell you, when you make it to Math 111, this is one of the special patterns that they may have you memorize to be faster at multiplying and or factoring. Okay, but for us now, let's just take our time to do these as super distributes. One more example before I, like I said, add a little twist. So I'm teaching you as a super distribute, not as FOIL, so that whenever I add extra terms, it's no big deal. So let's go with 2x plus 3 as a polynomial, and let's multiply it by a larger polynomial, like 2x squared plus 5x minus 3. Oh, wow. So is this going to be any more difficult? And the answer is no. I just have 3 terms here. And so what I'll do is I'll take my time to do my 2x distributed and my 3 distributed, and we'll be okay. 2x times 2x squared, that'll be 4. Let's see, 2 times 2 is 4. What's x times x squared? If we do some scratch work, there's got to be an understood exponent of 1 there, and when I'm multiplying like bases, I add the exponent. So that'll be 4x to the third. We won't always do scratch work. We should get kind of fast at this. 2x times 5x, that's a positive 10x squared. And 2x times a negative 3, that's a negative 6x. Okay, nice. The 2x has been distributed. Let's distribute the 3. 3 times 2x squared, positive 6x squared. 3 times a 5x, positive 15x. 3 times a negative 3, negative 9. So now I do need to be careful and look for like terms. Let's see. I have 4x to the third. There's no other x to the third. Let's bring that down. I do have 10x squared. Ooh, right here I have plus 6x squared. So that'll make a positive 16x squared. I have minus 6x and plus 15x. So what would that give me? That would give me a positive 9x. And then I have this minus 9. So I've combined all the like terms and ended up with that. So this feels exactly like simplifying. I need to do these super distributes and then combine like terms. That's all it is. It's the same type of simplifying. Distribute and combine, DC. So let's give you the one little twist I was talking about. Well, like we did in the section 1 of this chapter, we involved function notation somehow. We can involve function notation here as well. So I could do something like define g of x to be x squared plus 6. And then I could ask you, now here's the whole point of functions, is I can plug in more than just a number or a variable. I could plug in an entire polynomial. Find g of x plus 2. This is where our nice proper skills of plugging in would be very useful. Remember, if I'm going to plug into a function, I would like to rewrite the function with a blank where the x goes. And so blank squared plus 6 is the function. Well, what are we plugging into the function? X plus 2. So what goes in my blank? X plus 2. Now I would like to simplify this. Wait a second, we've done something like this already. X squared, x plus 2 squared, oh, that's just going to be x plus 2 times x plus 2. Don't forget to bring down the plus 6. Okay, I believe we can handle this. I'll need to do my super distribute, then combine like terms. X times x is x squared. X times 2 is a positive 2x. 2 times x is another positive or plus 2x. And 2 times 2 is a plus 4. Don't forget to bring down your plus 6. Okay, nice. Now, do I have any like terms? I believe I do. Let's see, x squared is a single term, so let's bring it down. I have 2x plus 2x, that's plus 4x. And I have 4 plus 6, that's plus 10. Beautiful. So we can even use function notation, and inside of simplifying that function notation, I could have some polynomial multiplication pop up. Awesome. So a few sections ago, we added and subtracted. Today, we multiplied. Next class, we may want to look at being able to divide polynomials. We won't do very too deep of division. We're not going to do long division or synthetic division. We'll do just dividing by a single term polynomial, a monomial. And then we'll start some factoring. Okay? But take care, and until see you next time.